Hello everyone, a very warm welcome in the discussion of AIATS plus 2025 phase 2 mock test 2. And yes, this is the paper which was conducted on 26th of January. You all are aware, I know. Since morning, we have discussed number of questions, number of concepts, but now this is the turn to understand few more concepts, few more related concepts in your NEET chemistry preparation. I'm Nidhi Panwar, your chemistry faculty, and definitely I'll be taking some of the important questions and the underlying concepts. Why we are studying these concepts simultaneously with respect to the question, just to understand that what is the basic need to identify to solve that question, right? So we'll be focusing on that. Don't worry, I'll be taking questions one by one. I'll be telling you the reasons why some option is wrong, and that will be continued. Okay, very good morning. People started joining, and this is the very good thing that you all are continuously responding over here. So this should be a dialogue. I'll be speaking from here. I'll be asking question. You should answer simultaneously, and whenever you find any difficulty, you find any question, you ask me here. Keep me posted and I'll be answering, right? Let me just start the discussion. And chemistry, it has lots of mystery while you have solved several questions in the paper as well. So those questions I've taken here. Have a look on the first question, the question number 51 for my part actually. Match list 1 with the list 2. So when I'm talking about this particular question, then what we need to do, this is the matrix match type of question. The pattern is pretty clear that you have the two lists with you. In the first list, some of the characteristics being mentioned, and in the list 2, some numbers are given. And what I observe as a chemistry teacher and as a chemistry student, you can understand that they are talking about the n value. It may be the principal quantum number. One thing I need to do that I missed here to take the pen. So let me just take my pen from here. Okay, so this n, what this is representing? This is principal quantum number, right? And in the second value, this is 2L plus 1. So what that L is representing? Azimuthal quantum number. So some of the things we identified. Very good morning, Josh, Dorado, Dashrath Sharma, Ishani, everyone good morning. Those who have posted your comment, for them also, and for others who have joined. Okay, so what we are discussing here, the matrix match type of question it is. Carefully, we need to just look at the columns given here. In the list 2, we identified that they're talking about the two main quantum numbers. One is the principal quantum number, or other is azimuthal quantum number. And what are the characteristics over there? Just have a look. Here they are written number of orbitals in a subshell. Further, number of subshell in a shell. Maximum number of electrons in a shell. Maximum number of electrons in a subshell. So what we identified so far, that they are talking about an atom, how electrons are distributed there, what are the things, what are the shapes where the electrons can be present. So it can be shell, it can be subshell, it can be orbital, right? So we need to understand that what is asked in the question. So while you are solving a question, there may be the two phases. One, while you are preparing, you have to understand the underlying concept. And while you are taking question during the exam, at that time, you need to check what is given and simultaneously what are the options. Okay, so these are the two ways to identify how to write the answer. Okay, so what I observed so far, that they are talking about the distribution of electrons in the shell or subshell, and simultaneously they are talking about the presence of subshell in shell or the orbital in the subshell. This is the question which is related to this, and the topic from which it's been taken, structure of atom. Now, I know that you have studied structure of atom carefully, an important concept also you are able to understand. So if I'm talking about the distribution of electron in an atom, how these are distributed. So one thing is the very clear that centrally located nucleus is there, and around that what we assume that shells are there, then subshells are there, and further orbital. Orbital is the place or the 3D space where maximum finding probability of an electron is there. So these are the basic concepts, those you already know. How to apply here? See, in an atom, the shell is there, right? And this is understood with the help of principal quantum number, right? principal quantum number. What is the denotation for this? How do we represent it? How do we represent principal quantum number? Because the question is related to it only. N value, right? And further, we have subshell, right? To know about subshell, we need to look at azimuthal quantum number. Am I right? And how do we represent? I can't understand what topic you are studying. Okay, so Sadia, we are talking about the topic structure of atom. The question which we are focusing on is from AIATS Plus paper. I hope you know about this Plus series. This is basically the personalized learning for ultimate success. So question I've taken from that paper. Yes. Anyone is here? Everybody is here, Sadia. So Sadia, the question is from the structure of atom and it is actually relating the electronic distribution in shell and subshell, right? That relation we are looking at. Okay, Pragati joined. Hi Pragati. So, what we were discussing, just have a look on it. In between, if you find any question, you can ask simultaneously in the comment, okay? So, what I was telling you that with respect to the question, we have to certain terms, those we need to look at. So, first, shell if I'm talking, principal quantum number we need to look at. Then, subshell, azimuthal quantum number denoted by L. Am I right? Okay. Now, if I just ask you that in a particular shell, how many maximum number of electron can be present, right? Once more. So, Rahul. So, Rahul, what we were looking at, that we were talking about the presence of electron in a shell. So, if n is the principal quantum number, then the number of electron in that particular shell is 2n square, right? This is how we proceed. Okay, Rahul? So, people are writing answer as well. Good, Ashwarya, 2n square. Right, 2n square. So, suppose I'm talking about the first shell, then how many electrons would be present there? This is the very basic concept that you have studied in the previous classes as well, not in 11th standard, only in 10th standard also. This 2n square, Bohr-Bury scheme of the filling of electron, right? So, in the first shell, if n is 1, then only 2 electrons could reside in the first shell, right? If n value is 2, then how many electrons could reside there? In the second shell, just answer me. In the second shell, if n value is 2, then 8 electron could reside there. Okay. So, in the first shell, 2 electron. In the second shell, 8 electron. And this way, electrons are filled in the shell. So, now, maximum number of electrons in a shell. So, this we identified, isn't it? C is matching with the fourth one. Okay. Now, further, the maximum number of electrons in a subshell or the number of subshells in a shell, that we just want to match here. So, number of subshells in a shell can be identified by the principal quantum number only. Suppose I'm talking about the first shell. First shell. Then how many subshells could be there? These are equal to n only. In the first shell, there is only one subshell, right? With respect to this n value. If n value is 1, then only one subshell would be there. Okay? 2, 8, 18, 32. Right, Aishwarya? But there are several other restrictions. Not only 2, 8, 18, 32. We need to follow Aufbau principle for the filling of the electron. Right? Now, first shell has one subshell. What about second shell? How many subshells would be there in the second subshell? N only. 2 only. Right? 2. 2 subshells would be there. What are the names of those subshells? Yes. So, these are S and P. In the first shell, only S subshell is there. Right? Now, similarly, if I'm talking about the third shell, then once again, with respect to the principal quantum number, there would be 3 subshells. And these are S, P and D. In the fourth one, S, P, D, F and further so on, right? So with respect to the number of shell, we can identify the number of subshells present there. So this way, this B is matching with the first one. Done. So what I'm doing actually here, one by one, I'm relating it. Okay. So hope this is clear as well. Now further, the number of orbitals in a subshell. How to find it out? So whenever I'm talking about the orbital in the subshell, so see here, if I'm talking about the S subshell, it has only one orbital, and that is S itself, right? Now, when I'm talking about the P subshell, how many orbitals are there? 3 p orbitals are there. I hope you know. Px, Py, and Pz or Pz, whatever you say. Okay. So 3 orbitals are there in P subshell. So how this number could be related? With the help of L value, with the help of azimuthal quantum number, you can identify the number of orbital in the subshell. And what that formula is? That is 2L plus 1. In a particular subshell, the number of orbital depends on azimuthal quantum number, that is 2L plus 1. So where we need to match it, number of orbital in a subshell would be matched here with the second one, right? The only one is left now, and who are already answering the option 4 are absolutely right, that I initially mentioned, that I've already mentioned here. Okay, now further, what is left behind, you know, the fourth one, the number of electrons in a subshell. Now my question is, suppose you have a particular orbital, okay? In that orbital, how many electrons could be filled? Suppose I have a single S orbital. How many maximum electrons could be filled there? Tell me. Anyone please write in the chat box. Only 2 electrons can be filled there, right? Only 2 electrons in a particular orbital, right? And suppose I'm talking about S subshell, there is only 1 orbital and 2 electrons can reside there. So in S subshell, the 2 electrons would be residing. In P subshell, there are 3 P orbital. Yes, Aishwarya, I got your answer. 3 P subshell, and each of these, you know, P subshell has 3 P orbitals. So don't be confused. Subshell is P. Inside that, there are 3 P orbitals, Px, Py, Pz, right? And each of these orbitals have 2 electrons. So in total, in the P subshell, 6 electrons can reside. So how we are identifying that? If the number of orbital is 2L plus 1, then number of electron would be double of it, isn't it? So what I'm going to do? I'll just mark double over here, this way. So it becomes 4L plus 2, right? Okay, so this D is matching with the third one. So absolute match is there. So Kanya wrote the answer, option 4 Aishwarya wrote the answer. So everyone who are just thinking to write the answer, who know the answer, you are right. But if you are not aware or somewhere you find it difficult, you can just learn the simple formulae, and this matrix match is actually going to help over there. Okay, so now we have matched it. Now let's see. A is matching with the second one, B is matching with the first one, C with the fourth, and D with the 3. So option 4 is the right answer. And in this question, there is no scope to go for the other option because other options are the simple other matches. So the right match we have identified here. I hope this is clear. If you have any query, you can write there in the comment section, right? Okay, let me proceed. Now I'm taking the next question. The question which is asking you to find out the correct order of ionization enthalpy. The question is for you all, that what ionization enthalpy is. Enthalpy, that is basically that representing the heat content of the particular process, right? And when I'm talking about the ionization process, it means you are removing an electron from the valence shell of an atom, right? मैम थोड़ा हिंदी में भी बोल दिया करिए. Okay, Anamika, I will try. Okay, but I'll be continued with it. ठीक है, बात करेंगे इसी पे. So correct order of ionization enthalpy की बात कर रहे थे. So ionization enthalpy is the enthalpy change when you are removing an electron from the valence shell of an isolated gaseous atom. Terminology in chemistry is very important. So Anamika, definition we need to take in English only. हमें terminology तो English में लेना ही पड़ेगा, है ना? And Anamika, one more thing, you are going to be doctor. You have to just practice on English as well simultaneously, okay? So, let's come back to the question. Correct order of ionization enthalpy is. So, if I'm just looking at the given option, because while solving the question, to check the option is very important. So, all the elements which are present here, lithium, beryllium, boron, carbon, nitrogen, oxygen, to which period of the modern periodic table these elements belong? Undoubtedly, these are the elements of second period. Am I right? Let me rewrite it. Okay? So, these are the second period element. What is the general trend of ionization enthalpy? You know, as you are moving down the group, atomic size increases generally, okay? I'm not talking about the p block element. There are several anomalies, right? Inert pair effect is also there, and you know, screening effect is also applicable for, but the general trend, if I'm talking, as you're moving down the group, atomic size increases and it becomes easier to remove an electron, right? So less amount of energy is needed for the removal of that electron, or simple to say, as you're moving down the group, suppose I'm talking about the group 1, alkali metals, right? So as you're moving down the group, it becomes easier to remove an electron because the nuclear charge, effective nuclear charge is less for the valence electron in that case, and removal of electron is easier. While I'm talking about moving left to right along the period, what happens? One by one electron is increasing as we are moving from lithium to oxygen or further to neon, right? But we are not considering the rightmost element, noble gases we are leaving here. We are here till oxygen only. So as you are moving left to right, the nuclear charge consistently increasing, right? And as the nuclear charge increasing, effective nuclear charge is increasing, it becomes difficult to remove an electron. More and more amount of energy is needed, and the atomic size is also decreasing as you are moving left to right. So that makes general trend says that ionization enthalpy increases. But in this case, what happens? In this case, what happens? We have the certain anomaly in between. What type of anomaly is there? So basically, if I'm talking about these elements, I'm just trying to draw a graph so that you can recall. You know, here I'm taking the first ionization enthalpy in kilojoule per mole, suppose I'm taking, and the elements from the atomic number 1, 2, 3, 4, 5, 6, 7, 8, and say 9, 10. ये भी ले लेते हैं. 9, 10. So all the elements I've just marked here with the help of the atomic numbers, right? These are atomic numbers. Now, you have atomic number here, increasing ionization enthalpy here. For the third element, that is lithium, suppose this is just representing, let me rewrite here. So this is, say, lithium, 520 kilojoule per mole somewhere here, okay. Now the turn comes for the beryllium, so it is increasing, and for beryllium, say here, this is beryllium. Now for boron, it is a bit less, right? Further, it is increasing after boron till carbon number 6. It is increasing till carbon. Here's the carbon, and after carbon, nitrogen. So nitrogen is increasing further for the nitrogen. But for oxygen, it is comparatively less for oxygen, and then further, it is increasing for fluorine and neon. So I'm writing here, say it is here somewhere fluorine and here for neon. So this type of graph you will find here, there in the NCERT as well, this graph is given. So there are the two difference we found. See, one for the beryllium and one for the nitrogen. If beryllium and nitrogen are not there, we are getting the straight line here, like continuously this is increasing, right? Because the atomic size decreases, effective nuclear charge increasing, so more amount of ionization enthalpy you need to provide there. The energy needs to be provided more there for the removal of an electron from the valence shell of this isolated gaseous atom. But, you know, if I'm talking about beryllium, so you are removing electron from the configuration 2s2. Atomic number 4 for the beryllium, right? So it is 1s2, 2s2. This is the configuration. From the s orbital, you are removing the electron. And in this case, the screening effect is more for the s subshell as compared to boron, which is having the configuration 2s to 2p1. So removal of electron from the p subshell is easier. This is the paired electron, and simultaneously screening effect is more. Removal of electron from the s subshell is difficult comparatively. So that's why beryllium has higher ionization enthalpy. Further, ma'am, thoda slow boliye. Okay, okay, Satyanarayan. Okay, so thoda slow bolte hai. Okay, so beryllium, if I'm talking, 1s2, 2s2 is the configuration. Because of the shielding effect, because of the s subshell, you need to provide more energy. And ionization enthalpy, first ionization enthalpy for beryllium is more as compared to boron, right? Then further, for the carbon, and it's a regular order. But when it comes to nitrogen, what happens here? In case of nitrogen, the configuration is 2s2. I'm talking about the valence shell only, 2p3. And 2p3 means half-filled configuration. Half-filled is as stable as fully filled. It is considered. It means it is difficult to remove from this stable configuration. It is difficult to remove an electron from this stable configuration. So more amount of ionization enthalpy you need to provide, and that makes higher value for nitrogen, and then regular. And for neon, that is the maximum one, because this is the noble gas, small size, high ionization enthalpy is needed. So the order would become now different from the regular one. What happens here? The lithium will come, then boron, then beryllium, carbon, then further oxygen, and then nitrogen, right? The order is correctly matching here with the fourth one. Done? So this type of question you will find from this chapter. The chapter is periodic classification of element, or the periodicity in the properties, right? So there can be a question that you need to identify the order of the electron gain enthalpy. I hope you know that most negative value of electron gain enthalpy is aligned with chlorine, not with fluorine. Fluorine is most electronegative element, but the most negative electron gain enthalpy is aligned with chlorine. Some of the things you need to remember, okay? Now, after completion of this, the turn comes for the discussion of the next question. So I'm just moving forward with the next question. That's a question number 55. Okay. So just check and tell me which chapter you will study to solve this question. Just let me know the name of the chapter. Right here in the comment section. Till then, I'll just read the question. So ammonia combining with BF3, boron trifluoride, and there is the formation of this compound. This is an adduct which is formed here. What happens here? See this type of bond, what this is? This is a coordinate bond, right? So what this is actually representing? It is representing that there is the loss, there is the one-sided sharing of the lone pair of electron from nitrogen to the vacant orbital of boron. Now let's understand this. I'll be telling you, don't worry. In this question, you have to just find out that in this reaction, which of the following is true, and what they are asking for. You need to identify whether it is the change in hybridization of nitrogen, change in hybridization of boron, change in hybridization of both of them, or none of them. These are the options. So how to solve this question? You should know that what hybridization they already have and what happens to their hybridization after combination, right? So how to find out hybridization? A simple trick. Just identify the steric number. The steric number is nothing but the sigma bonds which are present in the species plus lone pair. I hope you know this. And this we are looking at the central atom. Okay. Now suppose I'm talking about ammonia, right? In case of ammonia, 3 hydrogen atoms are bonded with nitrogen. So one thing is pretty clear, that there are 3 sigma bonds. At least 3 sigma bonds are there. Okay, now nitrogen, the valence shell has the 5 electron, 3 are involved in the bonding, sigma bonding with hydrogen atom. Then how many lone pairs are left? Definitely 1 lone pair is left. So 3 sigma bond, 1 lone pair. Done. Now steric number comes 4 here. Okay, when the steric number is 4, then what would be the hybridization? This leads to the hybridization sp3, right? Got it? If you are able to understand, that's okay. Otherwise, see, steric number is nothing but sigma bond plus lone pair. Suppose this comes 2, then what you need to do? You have to just look at the orbital. Only 2 orbital would be involved in the hybridization. Then definitely one s orbital would be there and one p. This way. Done. If steric number is 3, then hybridization would be 1s orbital and 2p orbitals would be there. This way you can find out hybridization easily. Same ways for the 4 you have already identified sp3. Now for 5, undoubtedly 1s, 3p, maximum 3p would be there. Then further, what left? 1 d orbital we need to take from here. sp3d or dsp3, right? 3 for bf3, sp2. Okay, Aishwarya, good. Now 6, suppose sp3d2 or d2sp3, right? So this is how we identify hybridization. For nitrogen, in case of ammonia, the hybridization is sp3. So if hybridization is sp3, which shape is aligned with it? The shape should be tetrahedral. Tetrahedral. In this tetrahedral structure, one nitrogen atom, it's not planar, it's tetrahedral, and one lone pair is present there, right? So what is, what's the shape this? Which term we use for this shape? Is this a pyramidal structure? Is this a pyramidal structure? Can I mark this? Isn't it? Right? And what happens? Recall the VSEPR theory, valence shell electron pair repulsion. In the valence shell, if electrons are present, definitely electrons would be present there. Electrons present in valence shell are repelling each other, right? And maximum repulsion is aligned with lone pair, then lone pair, bond pair, and then what next? Bond pair, bond pair. So what happens in case of ammonia? There is a repulsion between lone pair, bond pair. Here the hydrogen, these bonds, these sigma bonds are also repelling each other. So bond pair repulsion would be there. Further, bond pair repulsion is here as well. So in total, if I'm talking about the bond angle for the ammonia, that should be the bond angle of the tetrahedral angle. What that is? 109 degrees 28 minutes of arc. But that is not there. The bond get distorted, and that angle is 107 degrees. So this is all about ammonia. A lot I told you. But in this question only we need to understand that what is the hybridization of ammonia, that is sp3. Now what happens? It combines with BF3. So Aishwarya, you already told that BF3 has sp2 hybridization. Definitely, because in case of BF3, single boron atom bonded with 3 fluorine atom, right? So how many sigma bond? 3. Is there any lone pair on boron? Definitely not. Empty orbital it has. Vacant p orbital it has. And that is why it is also considered as exception to octet rule. It is also acting as Lewis acid due to the deficiency of electron, or simple to say vacant orbital, right? So ये Lewis acid भी हो सकता है, ये octet rule का exception भी है, incomplete octet, right? So now the shape is planar for this. Trigonal planar structure it has. The bond angle is 120 degree. But what happens? When ammonia comes in contact with it, it provides its lone pair in the vacant p orbital of boron, right? So now the hybridization of boron would be changed. How? Here it was sp2, because 3 sigma bonds are there, not the lone pair. sp2 is the hybridization, but as the lone pair from the nitrogen comes, so lone pair would also be counted for it, and the hybridization get changed into sp3. So there is no change in the hybridization of ammonia. There is no change in its planarity. It is already pyramidal. There is no change. But in case of BF3, its planar structure gets changed into tetrahedral, and simultaneously its hybridization is also changed, right? Now, on the basis of this discussion, easy to opt for the right answer. Just check. Question was, from the above reaction, which of the following is true, right? And the first option is, change in hybridization of nitrogen take place? Definitely no. And change in hybridization of boron take place? This is right. Other two options are contradictory. We cannot choose them because change in hybridization of both nitrogen and boron is taking place. This is incorrect. And no change in hybridization, it is also incorrect. So right answer we identified. Simple question, but you should know the concept, then only you can apply. Okay. Now just give me a thumbs up or tell me that you understood the concept so that I can proceed further. बताइए, सत्यनारायण मंडल, आपको समझ आया? चलिए आगे बढ़े. Continuation में आगे बढ़ते हैं. We have the next question, and the question is the magnitude of hydrogen bonding. So this is the question from, once again from the chemical bonding. The question is hydrogen bonding की बात करने वाले हैं. The question is, given below are the two statements. Statement 1 says the magnitude of hydrogen bonding of a compound is maximum in its solid state. The first statement. And the second statement is pH3. What pH3 is? Phosphine. Pragati. Okay, beta, thank you for confirmation. Statement 2 says pH3 or the phosphine does not show hydrogen bonding among its molecule. Now you need to just check. You need to just read the statement and opt for the correct answer from the given options. Statement 1 true, statement 2 false. It means you need to identify whether both the statement correct or not. Okay? Yes. Okay. Thank you, beta, for the confirmation. Okay. Now, first statement is the magnitude of hydrogen bonding. So, first question is what hydrogen bonding is? The last topic from the chapter chemical bonding and the molecular structure, hydrogen bonding. A special type of molecular interaction, and it is of two types, intramolecular and intermolecular. Remember? Okay. So hydrogen bonding कैसे होगा? Ubaid, you wrote the answer as well. Option 3. Okay. Let me just check here. So hydrogen bonding. Suppose some electronegative atom you have, and if it is bonded with the hydrogen, I'm talking about the most electronegative atom, fluorine, suppose, and if it is bonded with some hydrogen atom, so HF is formed. Right? Now, among these two, because of the high electronegativity, fluorine will attract the shared pair of electron towards itself. What's the definition of electronegativity? This is simple, that it is the tendency of an atom. This is qualitative term. It's the tendency of an element to attract the shared pair of electron towards itself, right? And fluorine is number one in it. What it do? It attracts the shared pair of electron towards itself. Ab electron iski taraf aayega, then what charge it would have? I'm not talking about the breaking of bond. I'm just talking about the attraction of the electron. So as electron gets shifted to this fluorine, definitely it will acquire partial negative charge. The simple concept, the simplest concept I should say. Hydrogen would get the partial positive charge, right? Now suppose other HF molecule come in contact. Definitely if I'm talking about hydrogen fluoride, then single molecule would not be there. Lots of molecules are there. Then definitely other HF molecule will also show this type of charge separation, right? And there is the, though weak, but type of interaction, right? Attractive interaction. So this is hydrogen bonding formation. And electronegative atoms like fluorine, I'm sorry, missed my pen. Fluorine, oxygen, nitrogen. These are showing this. If suppose I'm talking about HCl molecule, it does not show hydrogen bonding. It's not showing. But suppose I'm talking about water molecule, a very good extent of hydrogen bonding is there in case of water molecule, and this is the reason why ice has its specific structure. This is the reason why water molecule has very high boiling point. with respect to its molecular mass, its boiling point should be low. But when it comes to the actual water molecule, it has high boiling point, 100 degrees Celsius, because of the hydrogen bonding, right? So these important thing, it has same ways for the ammonia, possibility of hydrogen bonding is there. So this is about hydrogen bonding, and what hydrogen bonding so far we talked about, it was intermolecular hydrogen bonding. But when it comes to intramolecular, what happens? So intramolecular hydrogen bonding occur within the same molecule. And the example, the very well-known example, even in your NCERT as well, it is given. Orthonitrophenol, remember? So here is the attractive interaction. Hydrogen bonding is there. Intramolecular hydrogen bonding. The two type of hydrogen bondings, one is intermolecular, another is intramolecular. So this type of question are also very famous for the with respect to the NEET exam, that whether this species has intramolecular hydrogen bonding or not, or the specific species has hydrogen bonding or not. So that type of question is there. Same ways in this question as well, the magnitude of hydrogen bonding of a compound is maximum in its solid state. So this is the one of the feature of hydrogen bond, that as the compactness of the molecule increasing, it means in the solid state molecules are more compact, and simultaneously hydrogen bonds are also there. So extent of hydrogen bonding would be more in case of solid state. So this is the right statement. Now the second statement, pH 3 does not show hydrogen bonding among its molecule. So while this entire discussion, I just told you that atom which is bonded with hydrogen should be electronegative, and its electronegativity should be pretty high. When I'm talking about phosphorus, it is not that electronegative. It is not that electronegative. It means we can say it is less electronegative. So that it's not able to form hydrogen bond. Now अगर ये hydrogen bond नहीं बनाएगा, because the size is also large for this phosphorus, right? Suppose I'm comparing nitrogen and phosphorus, it is larger in size, electronegativity is less, so not able to form hydrogen bond with other phosphine molecule, right? So this second statement is also correct, and both statement 1 and 2 are true, and Ubaid, you have wrote the answer in the very beginning, and definitely you are right. So I'm opting for the right answer, that is option 3. Clear it is? Okay. Now I am moving forward. So now the question number 60 we have. In the question, okay, so very important category of the question with respect to NEET, assertion reason type of question. Even in your board exam also, if you are in the 12th standard, you find that this type of questions are also there. Okay, so let's understand what is asked in this question. There are the two statements. One is assertion, other is reason. What assertion statement says? Boron cannot form BF6 3- ion. And the reason is given that boron does not have empty orbital in outermost shell. So my question is, boron, species, small species, 6 fluoride ions are present there, and this anion is formed, right? Now, if I just ask you to find out the hybridization of this species, just find out. Suppose it's formed. I'm not saying that it is not formed. Suppose it is formed, then what is the hybridization of this species? Steric number. 6 fluorine atoms are bonded with this, right? Or simple to say, 6 fluoride ions are bonded with this. Okay, so 6 sigma bonds, no lone pair. It means the hybridization should be sp3d2. Without thinking much, you just look at the number of fluoride ions bonded with it. 6 fluoride ions bonded, hybridization should be sp3d2. Is it possible for this? Definitely no. Why? Because boron, the species with the atomic number 5, the configuration 2p1. Now just think that in second subshell, is it possible to have d orbitals? No. If d orbitals are not present, then how it can show the hybridization sp3d2, right? And one more thing, the small sized boron atom bonded with 6 fluoride ions, how it will accommodate them? That's not possible, right? So if it does not have the d orbital, it is not able to form BF6 3 minus. The simple question, whether this is formed? No, the answer is no. The second question, that why it's not there? Because the d orbitals are not present in the second subshell. How d orbital can be there, right? So the question is pretty simple. Assertion is true, reason is also true, explaining the assertion, and the answer is both A and R true, and R is the correct explanation of A. Is this clear? Just let me know whether this question is clear to you or not. Okay, so answer is option 1 that I'm marking here. So in such type, one more type of question could also be there in the similar concept, very famous, that SiF4 SiF6 2 minus is formed while SiCl6 2 minus is not formed. Then answer is not the availability of d orbital. In that case, the answer is the size of the silicon ion, Si4 plus. This is the small ion, right? It can accommodate 6 fluoride ion, but not the large sized chloride ion. These cannot be accommodated with it. So this type of question it is that 6 large chloride ions can't be accommodated by small sized Si4 plus ion. Is it clear? Okay. So this is one more of category, and in this case reason is different because silicon has empty d orbital but it cannot accommodate 6 chloride ions. Okay. The turn is there to move for the next question, and the question is oxidation state of the central bromine atom in Br3O8. So oxidation state term is there in the redox reaction chapter as well, but in the chapter 3 also you find it. And why I'm taking this question in this chemical bonding chapter, because for the identification of the oxidation state, we need to just look at the structure and the bonding of Br3O8. That's why I've taken this question, okay? So suppose it's asked that Br3O8 is there and find out its oxidation state. So in general, what happens, what you will do, 3x minus 16 is 0. So x is equals to 16 by 3 plus. But what they are asking, the central bromine atom. In this case, we will not proceed this way. We have to just look at the structure of Br3O8. How this is bonded with oxygen atom. The bromine is bonded with the oxygen atom. Aishwarya, ma'am, in the previous case, how does BF3 bond with NH3? So NH3, in case of nitrogen, has a lone pair and boron has the vacant p orbital. So nitrogen is providing its lone pair to the boron, right? Casey, that's the case, okay? Now Aishwarya, you said the answer is 4. You are right. But I'll be showing you the structure. 3 bromine atoms are bonded together this way. And 8 oxygen atoms are also bonded. So this is the structure for tribromo octaoxide, right? Okay. And what is oxidation state? That is basically based on the electronegativity consideration of the 2 bonded atom. Now if I'm talking about bromine and oxygen, oxygen is more electronegative, right? And here its oxidation state is -2 in all of these species. In the peroxide, the oxidation state of oxygen is -1, right? And in this case, it is -2 for all of the oxygen atoms. If atom is bonded with itself, then there is no electronegativity difference. So we do not consider that bonding with respect to the oxidation state, right? So here, with the help of, with respect to this bromine atom, if I'm looking at, see, one bromine atom bonded with 3 oxides, or the oxygen atom I can say, right? So with respect to this, how much negative charge is aligned with it? -6. So it would have +6 oxidation state because there is no charge on it. Now further, on the central bromine atom, it is bonded with this or this, and with respect to 2 oxygen atom, the oxidation state would come -2, -2, -4 is the total negative charge with respect to this bromine, so +4 is the oxidation state for this. Same ways for the third one, again +6. And the question was oxidation state of central bromine atom in Br3O8. So what you need to do? You need to just mark the right answer. And the right answer is option 2, the +4. Hope it is clear. Okay, let's move forward. Simple, easy question that was, right? Now I'm taking the next question from the topic chemical kinetics, right? And the options are just numbers, so read the question carefully and get the answer. In case of numerical question, one important thing that you find that there is no question mark in options with respect to the option. You have to just solve it correctly and mark the correct answer. Okay. Now, the rate of disappearance of A is 3 into 10 raised to the power -2 mole per liter per second. Then the rate of appearance of C in the following reaction in mole per liter per second. So in such type of question, we need to just look at the average rate of reaction with respect to the species taking part in the reaction. Okay. So in this case, you have 2A plus 4B. And what it is doing, it is forming 7C. So how to represent the rate of reaction? Rate of the reaction is actually represented by the change in concentration of the substance which is present in the reaction with respect to time. So suppose that substance is reactant, then what you mark? Decrease in concentration of reactant with respect to the change in time or the time taken. So this is actually representing that how do you measure a chemical reaction, how much it proceeds. So just to identify the speed of the reaction or the velocity of the reaction, we consider the term rate of the reaction. And this is represented by decrease in concentration of the reactant. How the concentration of reactant is decreasing, how much it has been decreased from the beginning, and how much time it took. Say, suppose a reaction is there and here A is converted into B, right? Initially, it was 5 molar, say, and it was 0, when time was 0. And after 10 seconds or the 10 minutes, suppose some time is there, 10 minutes, and this is formed 2 molar and it remained 3 molar. So what is the change in concentration of reactant? Final minus initial only. So 3 minus 5, and in how much time? Say 10 minutes, right? So rate would be -2 molar minute inverse. Can I write this way? Change in concentration with respect to time. Okay. So how to represent the rate if you are representing with respect to reactant? Decreasing concentration. See, here this is the negative sign. This negative is not the mathematical sign. It is just representing the decreasing concentration. Okay. So R is minus D, the concentration of the reactant with respect to time. So this dR by dt is representing the change in concentration at a particular moment in the small time. Wrong way, this is lengthy. This is lengthy, but this concept needs to be understood, right? I am not able to read the names. Some shorts is written there. So this is the basic concept behind this question. Okay. Now suppose with respect to product you need to mention, then what will you do? Change in concentration of the product with respect to time you will do. Okay. So this is how we represent. Now suppose you have a balanced chemical equation this way, and here 2 is mentioned, say here 3 is mentioned, here 4 is mentioned, say. Okay. Now suppose with respect to this balanced chemical equation, if it is asked that find out the rate, then in that case we will follow the similar case, but this time it is representing the participation of the 2 mole of A, participation of the 4 mole of B and formation of 3 mole of C. It means these many moles are formed, and while we are representing the rate, we just represent it with respect to moles. Per mole we can consider it, okay. So this time it would be represented as decreasing concentration of A by dt, and same ways 2 moles are there, so we just divide it by the stoichiometric coefficient. So 1 by 2 dA by dt, okay. Now further, minus 1 by 4 dB by dt, and this minus is for the reactant only. For product, how do we represent it? 1 by 3, it would be plus dC by dt. So this is the simple thing that we need to do. If you know this concept, then only you can apply it, right? Now the question, let's check the question once again. The reaction is this. Then how do we represent the rate of reaction with respect to this? It would be minus 1 by 2 dA by dt equals to minus 1 by 4 dB by dt, that is equal to plus, because this is a product, 1 by 7 dC by dt. This is the simple thing, right? How to relate the disappearance of the reactant or the appearance of the product with respect to rate of reaction. Now the question is, rate of disappearance of A is 3 into 10 raised to the power minus 2. So this value, this is the rate of disappearance of A. This is given, what this is? 3 into 10 raised to the power minus 2. Right? Now, 1 by 2 is the stoichiometric coefficient that we have mentioned here, and you need to compare it with rate of appearance of C. So only these two terms needs to be compared. I'm not going to take B anymore from here onwards. I'll be considering A and C only, okay? So this is equal to 1 by 7 rate of increase in concentration of C with respect to time, right? You want to find it out, this value. So what I need to do? I have to just send this 7 to that side, okay? So the formation of C, the rate of appearance of C with respect to time is 7 by 2 into 3 into 10 raised to the power minus 2, right? So this is 1.5 and 15 sevens are 105. 10.5 into 10 raised to the power minus 2, and it could be simplified written because the answer is in decimals only. So we'll go to this only. Now it becomes 0.105. What? The unit? That unit is mole per liter per second. Done? Final answer marked here. The first option is correctly representing it. Clear? Let's move forward with the simple and the next question. That's question number 86. 100 ml of 2 molar H2SO4 solution is diluted by adding 400 ml water. The molarity of the resultant solution becomes. Very simple concept. If you know the molarity equation, what it is? Molarity equation is M1V1 is equals to M2V2 if you are doing dilution, okay? So now M1 is given, which is 2 molar. So I'm writing 2 here. How much volume is there? 100 ml. That's equal to M2. Just check M2. 400 ml. No. What they are saying? It is diluted by adding 400 ml to this 100 ml. So total volume is not 400. It is 100 plus 400. This is the important point, and M2 you need to find, right? So this is 200, I'm sorry, by, this is 500, so I'm considering 500 here. This is M2. 200 by 500, 2 by 5. 2 by 5 is 0.4 molar. 0.4 molar is the right answer. Just look at the option. In case of numerical, it's pretty simple. Find the answer, mark it, and get the full marks if you are marking it correctly, right? So some of the questions from the important topics we discussed so far, and here onwards as well. This session would be continued, but definitely the other link would be there. So stay tuned here on the Aakash NEET channel with the lots more concepts, lots more questions. All the very best for your preparation and for the upcoming exam. Thank you so much.